when we are talking about gases, all gases obey certain laws, okay? So even though gases have different properties, all the gases obey certain laws. They obey Boyles' law, Charles' law, and based on that we have the combined gas laws, and then we have Gay-Lussac's law combining volumes. In this video, I'm going to look at the three of these. Okay? So, what you need to know firstly is our definition, Boyles' law. And that states, and you have to have this word for word, at constant temperature. So that has to be present. So my temperature remains the same. The volume of a fixed mass of gas, again, at any one time I can only change a variable. So I'm leaving my temperature the same, and I'm also keeping the mass fixed. And the volume is inversely proportional to its pressure. What does that mean? Okay, so I have my container. Okay, and inside that container I have three particles, and these are gases, so they're going to spread as far away from each other as possible. What happens is that here my volume, remember, my definition is the amount of space an object takes up. Okay? So if I look at this, okay, I've a high volume, okay, so they've plenty of space to move around, and they're not under a lot of pressure. Okay, so a high volume means low pressure. Okay, that's what inversely proportional means. It means oppositely. So if one increases, i.e. volume, then inversely proportional to its pressure means pressure decreases. However, what happens if I decrease my volume of my container? So now I have my decreased volume. This occupies an awful lot more or less space than this, okay? And inside here I have my three particles crammed, okay? So now these particles are under high pressure, okay? So that is what inversely proportional means. It means that as something increases, i.e. volume, my pressure decreases. However, again, inversely proportional, as my volume decreases, the pressure is going to increase. And that is all you need to know on Boyles' law. You have to have a constant temperature, because obviously if I change my temperature, this is going to have an effect on it. So you have to have at constant temperature. Charles' law then, and that states that this time at constant pressure. So again, you need to be able to determine the difference here between constant temperature for Boyles' law, constant pressure for Charles' law. Again, the volume of a fixed mass of gas, and this time is directly proportional to its, and you have to have the word Kelvin in the definition, and I'll explain that in a minute. So to its Kelvin temperature, okay? What happens here, okay? So I again have my particles in a container. I'll only use two this time. And what happens is, if I increase the temperature, okay, these molecules are going to have more energy. And they're going to have more kinetic energy. Remember, kinetic energy is energy that is moving. So these particles, when they get energy, move more. Okay? So because of this, I need more space. And because I need more space, what actually happens is that this volume increases. Okay? So the volume of the container increases. Remember, directly proportional, as one increases, the other also increases. The reason why it's at its Kelvin temperature, remember, directly proportional has to produce a straight line graph through the origin. Okay? However, this happens at a temperature of minus 273 degrees Celsius. So if I was to graph it using my degrees Celsius, this is not directly proportional because it doesn't go through the point of 0, 0. Okay? So because of that, I have to add on my 273, and when I do that, I am on my Kelvin scale. So in the definition, I have to write Kelvin because it will only go through 0, 0 when I have it on my Kelvin scale. Okay, so we have to write Kelvin temperature in our definition. The final thing then is those laws combined, and there is a full slide on the notes. You don't need to know that. All you need to know is the combined gas law equation. And I'm not going to go into it in any more detail than saying it is this. P1 V1 over T1 equals P2 V2 over T2. And I am going to work through an example of that in a minute. Just on that, for this, we have always, because my Charles's law is in the Kelvin temperatures, my temperatures always have to be in Kelvin. And finally then, it doesn't actually matter whether my pressure is in pascals or kilopascals, or my volume is in centimeters cubed or litres. All that needs to happen is that the units must balance. So whatever I have on the left hand side for pressure or volume, I have to have the same for pressure or volume on the right hand side. And I'm going to work through a couple of examples now.